Welcome everybody. We've been given this question: integral negative pi over 2 to pi over 2 dx over 1 positive e raised to the power of x times sine raised to the power of 6x positive cos raised to the power of 6x. So after taking the integral to be equal to I, what I wish to do is I would like to utilize this property. So we know that integral, say a to b f of x dx is equal to integral a to b f of a positive b negative x times dx. So I would be utilizing this. So that would mean wherever x comes, we will have to use pi over 2 positive of negative pi over 2 negative x. So if I were to take this as 1, therefore 1 is rewritten as pi over 2 to pi over 2 and dx over 1 positive. Now x is going to be e raised to the power of negative x, right? Times, now there won't be any impact for this. So this can be written as it is sine 6 raised or sine raised to the power of 6x positive cos raised to the power of 6x. Okay. Now this can be further rewritten as integral negative pi over 2 to pi over 2 dx over, now e raised to the power of negative x can be written as 1 over e raised to the power of x times sine raised to the power of 6x positive cos raised to the power of 6x. Now if I were to take the LCM, this is going to give me e raised to the power of x positive 1 divided by e raised to the power of x, and you have dx there times sine raised to the power of 6x positive cos raised to the power of 6x. Limits are negative pi over 2 to pi over 2. Now I can flip this and rewrite this as e raised to the power of x times dx divided by 1 positive e raised to the power of x times sine raised to the power of 6x positive cos raised to the power of 6x. Limits are pi over 2 to pi over 2. Now let me take this as 2, and what I'm going to do, I'm going to add 1 with 2. So that would give me 2 times I is equal to 1 positive e raised to the power of x times dx negative pi over 2 to pi over 2 divided by 1 positive e raised to the power of x times sine raised to the power of 6x positive cos raised to the power of 6x. So this is what we get. So these two can be cancelled, giving me integral negative pi over 2 to pi over 2 dx divided by sine raised to the power of 6x positive cos raised to the power of 6x. Now what I can do is, because the degree is 6, it's an even form, I can rewrite this as 2 times integral 0 to pi over 2 dx divided by sine raised to the power of 6x positive cos raised to the power of 6x. On the left you have 2 times I. So 2 gets cancelled and you have now I is equal to integral 0 to pi over 2 dx over sine raised to the power of 6x positive cos raised to the power of 6x. So we have to integrate this. Then I'm going to rewrite this as sine squared x raised to the power of 3 positive cos squared x raised to the power of 3. Limits are 0 to pi over 2. Now this is of the form a cubed positive b cubed, which is a positive b multiplied with a squared negative ab positive b squared. So for a being equal to sine squared x, b being equal to cos squared x, we will have this as sine squared x positive cos squared x multiplied with we will have to, no, instead of this formula, what I would like to do is I will utilize this formula. A positive B I will use this 3AB of A positive B. So A cubed positive B cubed is going to be A plus B the whole cubed negative AB times A positive B. So if I utilize this formula, so let me use this. A cubed positive B cubed is A positive B, the whole cube minus 3AB of A positive B. So this is, if I were to take A is equal to sine squared x and B is equal to cos squared x, this is raised to the power of 3, negative 3 times sine squared x cos squared x times sine squared x positive cos squared x. Now this is nothing but sine squared x raised to the power of 3 positive cos squared x raised to the power of 3. Now sine squared x positive cos squared x is equal to 1. So hence we have sine squared x raised to the power of 3 positive cos squared x raised to the power of 3 to be equal to 1 negative 3 times sine squared x cos squared x. So this is what we have got. Now what I wish to do is I would like to, okay, let me take this and place it over here. So let me take this as 1. So 1 is going to be equal to integral 0 to pi over 2 dx over 1 negative 3 times sine squared x cos squared x. Now I'm going to multiply by 4 the numerator and the denominator. So this is going to be 4 times integral 0 to pi over 2 dx divided by 4 negative 3 times, I'm going to write it like this, 3 times of 4 times sine squared x cos squared x. Okay, fair enough. Now there is a formula, sine 2 theta is equal to 2 times sine theta cos theta. So by this formula, if we have say sine squared x cos squared x, then we can actually rewrite this quantity as sine squared 2x. Now how do I do that? So let me show you that. 4 times integral 0 to pi over 2 dx divided by 4 negative 3 times up. I'm going to have this as 2 times, or I would say is 2 times sine x cos x the whole squared. Right. So this is going to be equal to 4 times integral 0 to pi over 2 dx divided by 4 negative 3 times of sine 2x the whole squared. So I will divide by cos squared 2x. So what happens if I divide by cos squared 2x? So this is equal to 4 times integral dx divided by cos squared 2x divided by 4 times cos squared 2x negative 3 times. You have a sine squared 2x and you have a cos squared 2x. Fair enough, right? So it's going to be 4 times. This is going to be secant squared 2x dx divided by 4 times secant squared 2x negative 3 times tan squared 2x. Limits are 0 to pi over 2. 4 is there. Now I can rewrite this as this is 0 to pi over 2. So I want to change it to 2 times integral 0 to pi over 4. okay, and you have secant square 2x divided by 4 times secant square 2x negative 3 times tan square 2x times dx. Now, okay, we need to make the substitution. Let tan 2x be equal to some t. I differentiate this, I get secant square 2x, there is a 2 there, and a dx is there, dt is there. So I can take the 4 out, and 2 will be the 2 times secant square 2x dx. That is going to give me dt, okay, but there is a secant square 2x there. So we need to solve or simplify that first. So now there is a formula, secant square theta negative tan square theta is equal to 1. So secant square theta is 1 positive tan square theta. I'm going to utilize this formula. So if I use this, secant square 2x is equal to 1 positive tan squared 2x. So I substitute that there, 4 times of 1 positive tan squared 2x negative 3 times of tan squared 2x. This is going to give me 4 positive 4 times of tan squared 2x negative 3 times of tan squared 2x. I add up these two, I get 4 positive tan squared 2x. Okay, but tan 2x is equal to t. So this is going to be 4 positive tan tx, tan tx or tan 2x is equal to t. So this is going to be 4 positive t squared. So this is going to be t squared there. Okay, so now we will have to integrate this. So the limits have to be settled, right? So when x is equal to 0, 0. But when x is equal to pi over 4, this will become infinity. Right? Because pi over 2, tan pi over 2, that's sine 90 over cos 90. Right? So that's infinity there. So I'm going to rewrite this as 4 times integral 0 to infinity dt divided by 2 squared positive t squared. This is going to be 1 over a tan inverse of t, limits are 0 to infinity. So this is going to be 2 times of tan inverse of infinity minus tan inverse of 0. This is 2 times, or tan inverse of infinity is pi over 2. This one vanishes. So 2 gets cancelled, giving me pi as a solution for this question. It's a lovely question. Please like, share and support. Thank you everybody.